Okay, recording is on. So you all watched, I'm assuming that you all watched the Agile Unit Testing TDD video. Did you guys watch
Yes.
it?
Yeah, I did, Shubhan.
Excellent, excellent. Video, I'm assuming you practiced some examples or whatever I did there. I'm assuming, that's the prerequisite for today's class because I'm not going over all the concepts there. It is particularly important these days now because everybody is going towards agile development methodology. Particularly, everybody is using Scrum. Okay, so in Scrum, the user requirements are typically called user stories, and then you will do story pointing. Each story you will estimate how hard or how easy it is based on story points. Typically, they ask you in interviews also, hey, if I say I've used a Scrum, then they typically ask, what's your sprint cycle? Because each one of them is called sprints, and then sprint cycle. Typically 2 weeks or 3 weeks, 4 weeks, but typically 2 weeks. So all the agile teams are typically small teams, anywhere from 6 to 10, not more than that. So that's how they are set up. Some companies like Amazon uses a simple rule called two pizza rule. Two pizza rule meaning if a team can consume more than 2 pizzas, then it's too big, then they will further break it down. So, a lot of techniques. So in the same agile environment, this is mainly for project management side, and then absolutely the most important piece for all the developers. Okay, but there is one more flavor called XP, extreme programming. On the extreme programming side, this is mainly for developers and technical people. There are some techniques that they use. One of them is pair programming. Pair programming. In pair programming, not one person will code alone. So two people typically, in some, most of the cases, one senior guy, one junior guy, they pair up together. But it doesn't have to be that way. One guy will be typing, the other guy will be watching it. And so two brains, two pairs of eyes will be looking at it. Two brains will be thinking. And every 30 minutes or so, they'll change. One guy will be typing, the other guy will be watching, etc. That's what they continuously do. A lot of good agile teams, they tend to pair program, and it improves the quality of your software product extremely high. It will improve very well. There are a lot of companies, especially in Metro Detroit area, that practice pair programming. I'm in the Metro Detroit area, but everywhere. I think it's West Coast. It's where it's predominantly common. Or some tech companies, they do it. Here, few companies do it. I don't have to mention the names here, but anyways, it's a good technique. Especially there are, in Metro Detroit area, we have some companies like Domino's Pizza. So I think they are very, very good agile shop. And there is one software development company, Menlo. They're completely agile shop. And then Cengage, another company. It's Comerica Bank. And a couple of other places. So they do heavily their heavily into Agile. So paid programming. In addition to paid programming, they do something called TDD, test-driven development. So what it means is that you might have seen the previous video. That's why I'm not going over that completely again, but I'll recap and then we'll jump into some coding. Driven development, meaning test drives the development. You don't write the actual code and then write the unit test. Okay, so again in testing we talked about unit testing, integration testing, acceptance testing, several other kinds of testing. One particularly important testing that every developer should be very familiar and should be expert with is unit testing. So we must all do it, unit testing, and this is our responsibility. This is not QA people's responsibility. We all have to do unit testing, and one of the unit testing, widely used unit testing framework for Java is JUnit. A couple more frameworks, but JUnit is the most popular one. In fact, they have flavors like NUnit for .NET, etc. It is that popular. So, we typically use JUnit, but in TDD practices, what they do is first they will actually start with the test. They will start with the test case. So before you actually try to write something, you need to know what you're writing for. You need to know the business scenario. So what's the business use case? Okay, in this use case, in this scenario, the code should behave this way. In this scenario, the code should behave this way. In this scenario, the code should behave this way. In this scenario, the code should behave this way. So we have 4 scenarios and 4 expectations, right? And then so that's all I need to do, right? There are 4 scenarios, and I need to write code for 4 scenarios. That's all. I don't write the code for 5th scenario. Okay, it violates a software engineering principle called YAGNI. YAGNI. You ain't gonna need it. So what it means is you ain't gonna need it. You don't need it. If you don't need it, don't code it. Simple. You are not going to write a single line of code that is not required tomorrow. Not tomorrow, actually today. In more traditional style of software development, 10 years back when we were coding, 10, 15 years back, so we all started with waterfall methodology. And waterfall is actually not necessarily bad. It's just that it hasn't been perceived very well. It hasn't been understood well and practiced well. Let me put it that way. So that is why we used to do all the pompous, all the efferent architectures, a lot of good things, but we will never really use them. We used to spend a good 3 to 6 months on writing the utility classes, etc. The architecture setup. It's true. But here, with agile development methodology, the things have changed. Hey, always your success criteria will be tested or will be measured based on the end product. So every couple of weeks, keep pushing the software product, keep pushing the product, keep pushing the product. Let the actual users feel it and let them come back and say that once they feel it, they will say that, oh, this is not what I asked you to do it. In that case, you're only wasting 2 weeks. You're not wasting 2 months or 6 months. Anyways, so the point is you will not have a single scenario or single line of code. You will not write a single line of code without having the scenario. And it also making sure that every single scenario that you're going to write for will be tested because you are actually starting with the test. If there is no scenario to test, then you can't write the code. So every line of code will be tested. So every scenario will be tested. Every if-else condition will be tested. Every for loop will be tested. Every branch of code will be tested. So that's the beauty of test-driven development. So in the previous video you have seen, me test driving the calculator example. And now let's test drive more examples today. And let's see how we do it actually in the real world. Okay. And first of all, let's go ahead and download the JUnit jar. So you need both plain old jar. Okay, yeah, I need this one, JUnit jar. 4.12 is fine. So I need the jar file. Okay, I'm downloading it. And then let me get the ham crust jar as well. These are the JUnit, these are the two libraries that you need. JUnit and ham crust. Okay, so in Core Java Feb 2015, I'm going to create a folder called libraries, lib, and I'm going to put it both of them here. And then these jar files, as you have seen in the other, the previous video, I'm going to add them to the class path. Okay, now these are available for me to play with, right? These are available for me to play with now. Now let me create a package here. Training core TDD. Okay. So let's take our examples here. So coding questions, right? So I'll take a couple of examples and show you how to really test drive in real world. Showing this example, like whatever the example that I've taken in the last class, I believe, is reverse the string. Okay, I think we looked at the string reverser in not the agile video, but before that I actually did for you, right? So let me write down my. So first of all, I'm going to go ahead and create the actual unit test case. Okay, so I'll create the JUnit test case, and I'll call this one as sentence reverser, right? Or yeah, sentence reverser test. Okay. So what I'm doing here is that given a sentence, you need to reverse it. You need to reverse the words and give me back. That's the goal. Okay, that's what I've been. One of the questions here is, given a sentence that has words, you give me back a reversed sentence, a sentence that has the words in exact reverse order, right? Okay. So, as I talked in the previous, the Agile video, in TDD, the way it works is, let me recap it, okay? The first principle here is that red. Okay. So, first, before you start, write a scenario here and make it fail. Make it fail. The reason you make it fail is because when you write the scenario here, obviously you don't have the implementation there. So obviously it will be fail, right? So that is red. And then what you do is quickly make it green. Quickly make it green. So you are not writing code that is not required. So you're only going to satisfy this particular use case. This is the use case. Okay, this is the scenario, and this is the corresponding the actual code. You are quickly making it green, and then now refactor it. What is refactoring? Refactoring is nothing but changing the design of the code without changing the behavior. Okay, so improving the design of the code without changing the functionality. So now you make it, you refactor it and make any changes to the code. Okay, so improve your code is essentially what it means. And again, write a second scenario. Now write a second fail test case. So again, red, green, refactor. Now go to the third scenario. Again, red, green, refactor. Write fourth scenario, red, green, refactor. Every single time you introduce a new test or a new functionality, make sure all the test cases are still good. Because while making the second scenario successful, you may introduce a bug that will break the first test case. So always run all the test cases, and make sure that everything is good. Okay, let's see. Without delay, let's take a look at it. So red, green, refactoring. That's the mantra here. So obviously, so tell me the scenarios here. Tell me the scenarios, or probably I'll talk one scenario at a time here. We all know here. So tell me one scenario here. Probably if I give you one word, right? Let's say hello. If I give you one word, what should it give? When I give you one word, hello, what should it give? It should give me back hello, right? So first of all, let's make sure your code works for one word, right? If I give you one word, it has to give me the same word because there is nothing to reverse there, right? Okay, now let's make sure that. Let's write the test case for that. This is how we typically write. Okay. Sentence reverser.
Question. This is the one where we split the string and then we did a reverse for loop, right?
Yes. Yes.
Okay. Just making sure where we are. Thank
Yep. But we don't.
ఇంకా నా చెప్పాలండి ఎలా ఉంది కాల్స్ ఏమన్నా వచ్చినాయా లాంగ్ వీకెండ్ కదా
Sentence reverser should or let me say one word, right? One word input, okay, should return the same word. Make sense? So this is how we typically write the scenario. One word input should return the same word, right? Is that right? So now let's create the actual, obviously it will fail. Okay, it's not yet been implemented. So let's go ahead and implement it. Let's create the actual class here. I'll call it sentence reverser. Okay, Now, public string reverse string input, right? Yeah, input. Okay, I'll just say written now to start with. Okay, by the way, this fail is a method. It's a static method in your JUnit. JUnit has certain classes, right? JUnit has one of these classes called assert. Okay, actually there is something in JDK5 called static imports. If you don't know about it, forget about it. So what you do is assert.fail. This is how I'm calling it. org.junit.assert. So this assert.fail. So what it means is this assert class has several methods to make sure the output is correct. Okay, and one of the methods is just simply fail because we haven't implemented anything here, right? So what should I do now? Now I'll take out this guy, and now let's make sure. So string reverser equal to new string reverser. First let me instantiate it, guy. Sorry. First instantiate. Oh, sentence reverser. I'm sorry. So sentence reverser equal to new sentence reverser. So I instantiated this particular class. Okay. I instantiated this particular class, and now I'll say I want to make sure what is my input here. What is the first scenario here? If I give hello, I should get back hello, right? Now reverser dot reverse. Now I will give hello as the input. Now what I get is output, right? So did you all understand this method here? I mean, reverse is the method name. I'll give you the string input and I'll give you back a string. I'm currently not implementing anything, just returning now to make sure that my test class will compile. So I got the output now. Now tell me, what should be my output? What should this reverse method should have given me? Aruna, I'm not asking what it will give, but what it should give.
Ole.
You are thinking like a tester now, right? This is your testing, right? So now, no, it doesn't actually. It's not Ole. It's actually hello. We're talking about right? Assert has a method called
fail. Oh, okay, fail.
Assert has a method called assert equals. Okay. So here, what is your expected result? What is your expected? Expected is hello, and what is the actual one? The actual one is output. Did you all understand this line of code here? Did you all understand this line of code? So this is how we assert that. We don't have to write the system.out.println anymore. We don't have to. If you write the system.out.println, it will be printed on the console. Who will read it and make sure what we got the output is what we are expecting? This is what we are expecting, but what we got from it, we don't know. This is what we got it. I'm just checking.
Venkat, this assert class, is it same as the test case class?
Oh, there is in JUnit, there is a class called assert. This one has a lot of assertions. You know what is assertion? Assertion meaning you are ascertaining that what you get from code is what you are expecting. You are ascertaining here that, hey, this is my expected string. This is what I'm expecting, and what I got is output. So it will, behind the scenes, under the hood, it will just compare both of them. If it's not equal, then it will make your test case fail. Did you understand that?
Yeah.
Everybody? Everybody.
But I saw your video.
Go ahead.
Yeah, but I saw your
So in your video,
and there is a test case and there is same thing.
Oh, okay. Okay. I'm sorry.
Venkat, what is happening is you have used 4.10 jar.
Yep.
There we have a test case class.
I'm sorry.
And
Okay.
that's what I'm asking, if this assert
Yes,
and test
yes.
case class are the same.
Yes, absolutely. They both are same. Mine is probably good 3 years old. That is why. Sorry about it. That's the test case you're talking about. Yes, it's exactly same. That's a JUnit. Earlier, actually, it's not even org.JUnit. I believe it's it was maintained under. It was not Google code, but it was maintained under SourceForge initially. But now they are, org.JUnit. Yes, it is same. Sorry for the confusion. Now, did everybody understand that? Everybody understood this line of code? Okay. Now let's see.
Okay,
Now, yeah,
I have
go
got a
ahead.
question. See, in your this thing tape, I saw that there was assert also, but the test case that she's talking about, I didn't get that point clearly.
That's fine. I mean, forget about it.
That's not required. Okay.
So there is no point at all. Actually, it's the deprecated API. That's all.
Oh,
Meaning it's old API. This is a new API.
okay.
Simple. Okay. In fact, don't focus on that. Whether it is test case or assert or something else, that's not the point at all. So the point is, there is a method called assert equals. And now all we are saying is, if not assert equals, if you are designing this JUnit, you will call something else. Show one assert dot show one equals, whatever that one is, right? So don't focus on the methods or classes. The concept is, this is your expected value and this is your actual one that is coming from the real class, right? Now we are testing. All I'm saying here is that this is testing. This line of code is actually under the hood. JUnit will make sure what you got and what you are expecting are same. If they are same, it will make it pass. Otherwise, it will fail with a big red mark. Okay. Now right click, run as JUnit test. Hey, see here, this bar. This is a famous bar here. So now this is red and runs 1 and then error 0, failures 1. And now let's look at it. Assertion expected hello but was null. It is very famous assertion error that you have to be familiar with. Expected hello. So you are expecting hello, but what you got from your program is null, right? Because you did not implement anything, you didn't do anything. Now, this is your red part of it. So let's do the check of red-green refactoring, right? So let's go red-green refactoring. Okay? Red portion is done for this particular scenario. Now, how do I make this test case pass? Tell me, without implementing anything, how do I quickly make this test case pass?
By returning hello.
Excellent point. By returning, we can hard code that. Just say hello, right? That's it. So whatever the input you give, I will always give you hello. Excellent point. Now, right click, run as JUnit. Hey, now green is good. Test case passed. Very good. So your this one is passed, right? Now let's go. Now, before you actually go and refactor, is there anything to refactor? Is there anything to improve here? Not really. Okay, we're good so far. Now, let's write one more test case. Okay? Now, tell me, what is the second scenario? What is the second scenario? So this is one-word sentence, right? Now, let's talk about two-word sentences. If I give you, this is my way of doing it, but you can do it differently. Totally fine. So, let's say if I give hello world, okay, what should be the output? If I give this one as input, what should be the output? world, hello, right?
Same. Oh yeah, reversing is yeah. Reverse,
Right.
what's reverser? Yes.
So if I give hello world as input, my output should be world hello. Okay, let's make sure. So let me write another test case. Sentence with 2 words should be reversed, right? I know these method names are very verbose, and that's why some people use like this, sentence with 2, this style, or some people use it camel case. So I don't really have opinion on that. You whatever you think is readable, you go with it. I don't have strong opinion on either way. Anyways, sentence with 2 words should be reversed. Now, the instantiation is common. I instantiated it. Now let's look at the output. What is the input I'm giving? Hello world, right? Now what should be the output now? What should I compare with? World hello. Agree? And then whatever the output is, it will compare. So I wrote the second test case now. I'm making sure that my sentence reverser works for this scenario and this scenario. Let's go. I need to do red, right? Very good. So I wrote a red test case. This is the test case. So I have to make the code work for this scenario, right? So how do I quickly make it green? Tell me. How do I quickly make this green? How do I make this test case pass? Quickly.
Change the return to
Exactly. Change this one to world hello, right? Quickly make it green. Now let's make sure what we have the situation here. Oh, we made this test case pass, but this guy failed. The first one failed. So we failed the first one. That's not what we wanted to do, right? So we always have to make all the test cases pass. Now let's go here. How do I do that? How do I do that? Any ideas here?
My opinion is you cannot, because see, each one is expecting each string.
Right. So tell me. So what do you want to do in this case?
In this case, I would change the assert statement to both will have hello world, world hello or whatever.
No. You never change the test case. The test case will never change, right?
It's the same.
If I give you hello, what is the expectation here? My sentence reverser, if I give you hello, you have to give me hello back. If I give you hello world, you have to give me a world hello. So how do I quickly make this green without writing anything? Well, there is no good way. Okay. I mean, definitely you can write like this.
Okay, that's not the
Input dot equals, hello, right? Return hello. Okay. Else return world hello. Agree? Okay. Let's make sure. Hey, both the test cases passed without writing really any line of code. So we wrote 2 test cases. Two test cases are passed. Well, is there any way that I know this is actually not a real implementation. So probably we have to come back and think about real implementation at this point, or you can leave this way. Okay, you can leave this way and write the third test case here. Write the third test case. So how do I write the third test case? If hello should be returned, hello world hello should be returned. Now a sentence with more than 2 words should be reversed, right? How are you doing? Right? How are you doing should return doing, you, or how. Agree? And we know that these are space delimited. We know that the words are space delimited. That is the assumption. That's what business user already told you. So let's go and write the test case for this one. So sentence with more than 2 words should be reversed, right? Now, I'll give the input of how are you doing. Now, I expect the output doing, you, are, how, right? Now, let's go to the red side of it. In the red-green refactoring, this is red. Okay, good. Now, how do I make it green? Is there a way I can make this green? Well, else if I can do this, okay, and we'll come back and refactor it. I know we don't gain much here. Actually, earlier itself we can do it. If it's hello, hello, hello world, return world hello, else return how are you doing, right? Doing, what is that? Doing, you are, how. Right? Okay, how is, make sense? And make it quickly green. Well, all these 3 green. But does it make any sense? No. Actually, we hard-coded everything. We can go ahead and write one more test case, but it's not going anywhere. We have to refactor it. We are missing this third point, the most important point here, refactor. Not just making it work, but make it sensibly work. Refactor, right? Now let's implement the actual logic and see how it works, right? So how do we do it? Now we have the input, the actual sentence that is space delimited. So what we'll do is input dot split, and we will give space here, okay? And now we will get, what does it return? Mouse over it, it will tell you string array. So it will give you all the words that are space delimited, right? And now tell me, how do you want to proceed? How do you want to write for one word? Do you want to check the length and then do it? If words dot length equal to 1, what can you do? Meaning, if there is only one word here, is what I'm saying here. If I give you hello dot split spaces will only give me, in the string array you will only have one word, which is hello. So if at all the length is 1, then you just return hello, right? I mean return the input. Return the input. Right?
Yeah, input, yeah.
Now let's make sure. I'm deleting all this junk code now. Let's see. Okay. Well, I'll say else return, else null at this point, because I want to test only one at a time. So let's make sure that the first scenario is passed. Good, first scenario is passed. And second and third scenario, we haven't, really coded and refactored yet, right? So now,
Venkat, I didn't see the first scenario pass. I saw red though.
No, this is the
Did it flash green?
Yeah, see?
Oh, okay, I'm sorry. Yeah, I missed it, sorry. I was blinking an eye.
There are only 2 failures out of 3.
Oh, okay.
Right?
Got it.
Okay. Mm-hmm. Otherwise, now let's write the actual code now. We have to do the for loop, right? Right? Come on, one of you tell me. For int I equal to, we have to backwards, right?
0 to. Yeah. So what's dot length? -1, 2.
Exactly.
Length -1.
Sure. Thank you everybody. Words dot length minus 1. Okay, I
Equal to 0. Equal
Is
to
greater
0.
than equal.
less than or equal
Less
to
than 0.
0, as long as it is greater than or equal to 0, as long as it is greater than or equal to 0, right?
Because,
I minus
yeah,
minus.
I minus minus.
Minus.
I minus minus. Sure, we are doing reverse. I think this is we did this one before, so I don't need to explain this. And now we will get the words. How do I get the each word? Words of I will give me the words, right? I mean, this will give me the word, right?
Correct.
String, give me the word. Now let's go here, and then we have to add all of this to string buffer, right? String buffer or builder. Actually, I told you string builder gives you more, better performance than string buffer because this is not thread safe. So I will, each word as I get, I will add it to the one of these mutable containers, say the string buffer or builder. Okay, builder is better. String builder, reversed string equal to new string builder. Sweet. Now reversed string dot append, then I'll take this word and okay, I'm adding this one. And what else do I do? What else do I do? After the word
String builder, you need
exactly, I have to put what?
Return.
I have to put space, right?
Space. Yeah.
I have to put the space, right?
And
now
return that.
finally I will return reversed string dot toString.
Okay.
Make sense?
Correct. Sorry. Yeah.
Sorry. Now let's make sure whether any fail. Oh, actually, okay, it is failing. Yep, out of these three, only one passed. The second one failed. Why is it failing? Okay, you are expecting. You expected is doing you are how, but it was doing you are how. There is an extra space actually. There is an extra space. So what you are doing here is you are exactly getting doing you are how, and the same case with this one, world hello, but there is an extra space here because you are giving the space. Initially you are building world and then space and then hello, then again space. You don't want to give the space for the last one, right? Are you with me? Look at it. Look at it, guys. Here, are you looking at here? Here there is no space, but here there is an empty space. So you have an extra space here.
If you have to put an if over there, like you did last time.
If
I is not equal to 0.
If I is not equal to 0, excellent point. If I is not equal to 0, then you should append this space, right? Otherwise, I equal to 0 will be true only for the last one, right? Now let's make sure. Hey, all three test cases passed, right? All three test cases passed. Now, red, green, now refactor. So is there anything to improve here? Is there anything to improve here? Probably you can move, once you get all of these words, right, you can move all of this to a private method, because if you think this method is too big, okay, this method is doing too much, because you have here, if it's one word, you are returning it, and then you are also splitting it, and the whole logic is here. So you can move it to a private method. So you can do a simple refactoring technique here. Okay, move all of this to a private method called, just reverse it. I'll just say return reverse. and then I will return these words. Okay, and then I'll create a private method. Okay, and now I'll move these guys to a private method. Now I'm improving the code. Am I changing the functionality? Nope. I'm just improving the code. This code looks better now, right? Because this code is only doing so much, and I can do a format also. Yep, this formatting is good. I think everything is good now. But we wrote a lot of code already. So we did a lot of changes here. So we need to make sure every couple of seconds or every couple of minutes, okay, you need to make sure that all the test cases are still passing. Okay, all the test cases are passing. We did excellent refactoring. We're all good now. Everything is green. Now, let's make sure there is one more scenario. If at all.
So before you proceed, Venkat, before you proceed, just one interjection.
Mm-hmm.
That is the test program that you wrote.
Mm-hmm.
That test program is just a test. It doesn't have any, just has only the functions to be tested.
That's it.
But does not have the main in it.
Exactly. There is no main. We will not write main anymore. All these while we have been.
Yeah.
Go ahead.
Not in this one. In the sentence reverser.
In the sentence reverser, you will never have main anyway, right?
You won't have main. Okay.
Did we ever have main in any of the classes? No. Only the demo classes will have the demo classes will have main method, and now we replace the demo with the test classes, and no more public static void main. Rather, we want to do it this way, because public static void main, who will test all of this one? Who will make sure that what is the output and what is expected, whether they are true or not, and then who gives all of this fanciness here? Red bar, green bar, all of this, who will give it? So that is why we will be using JUnit from now onwards. We will not.
So our classes like our laptop and TV and all those classes, we will directly test with this.
Exactly.
Okay.
You should now start writing the test cases actually. In fact, if you want to do 2D TDD, you have to write the test case first and then write the actual code.
Okay. Another question.
Yes.
Is see for so what I understand is this JUnit has its own main or something like that, and when it gets this assert, the assert returns a boolean value, and based on that value it directly makes it green or red, right?
You got it. You precisely got it. Actually, when you right click run as JUnit, what is happening is you're actually kicking off one of the JUnit runners. That's what they call it. So that runner has a main method in it. That main method, using reflection, it will read all this this whole class. Okay, it will look for these annotations. Okay, and then within that public static void main in JUnit, it will execute this whatever you wrote here, and then it will compare these two, your expected versus the actuals, and then if they are wrong, then it will show you red bar, otherwise it will show you green bar, etc.
And the reflection, is it something that you discuss about, or is it necessary to discuss, or something?
It is very necessary to discuss. We'll talk about it later. Actually, that will be one of the homework videos. JDK5 new language features. There I talked about reflection. So
no problem.
Okay.
Thanks.
No problem. So we wrote 3 test cases, and at this point, you should think about your test class too, and see if you can improve this test class any better. You are violating a principle in software engineering called DRY principle, DRY. So DRY. You know what it stands for? Any of you? Any programming language experience? It doesn't matter what it is. It's common for all the.
Dry run, I know. Dry run or something.
No, DRY stands for Ruby guys, or any programming guys. Do not repeat yourself. So DRY stands for do not repeat yourself. It was mentioned in this great book. I think I was speaking to someone yesterday. I was telling few books that every software engineer should, I mean especially Java developer should have it. So these are the books that I highly recommend. One of the first one is the DRY, do not repeat yourself, has been mentioned in this book called Pragmatic Programmer. Pragmatic Programmer by Andrew Hunt, Dave Thomas, those guys. And then Effective Java by Joshua Block. Clean Code by Robert C. Martin. He's called Uncle Bob. And Refactoring by Martin Fowler.
Head first.
Head first, okay. Yeah, head first, okay. I mean, head first is very basic thing. I mean,
It's too much like a comic book actually.
yeah. I mean, head first Java is okay. Head first Java is okay. But these are all, you know, these are reference books that I'm talking about. You should have in your shelf that these are Bibles, you know. Yeah, you must read all of these books. Actually, there is a Head First series. There is a different book called Head First Design Patterns, but we'll talk about that later. That's an excellent, one of the best books. So anyways, you know, do not repeat yourself. So we are repeating ourselves a lot of times here. So I think it's, we shouldn't be repeating. So we repeated the same code, right? So in unit testing, okay, the way it works is that the way JUnit works, as I was just mentioning, there is a main method there in JUnit classes, JUnit runners, that's what they call it. Within that main, all of these methods will be called iteratively, okay? All the methods that have these annotation, at test, okay? Now, so, one second, guys.
Venkat, can you test one small program with a scanner input equal to new scanner system.in?
No, I mean, no, not today.
Okay.
Just 1 second. Huh? Sorry about it, Sean. Well, I wanted to do a couple of examples actually. Because input, I'm talking about the automation, and the input is never automated. That is why I was saying no for that specific example. I'll talk about that later. I'm sorry about it. Okay, so here we are repeating ourselves, right? So let's not repeat ourselves. So in JUnit, there is a concept called setting up and tear down. Okay, there is a concept called setup and tear down. So what it means is, this is one test case, this is test case 2, this is test case 3, right? So there is a special method that will be called before your test case. This is your test case 1. Before your test case 1 is called, your setup method will be called to do any necessary work that you need to do it before running the actual test case. So this is where you can instantiate the necessary classes. This is where you can actually connect to the database and hold on to your database connection. This is where you can probably point to a file and then get handle on file and hold on to it. You can do all that good stuff here. Before every single test case is run, your setup will be called. And then your test case will be called. And after the test case is completed, if you want to delete any of the stuff that you did as part of this one and bring it back to the original state, there is another method called tear down will be called. Meaning, in this particular example, your setup, okay, test case 1, tear down. This is how JUnit will call behind the scenes. And then for the second test case again, it will call that setup and then test case 2 and then tear down again. Again for the third test case, setup, test case 3, tear down will be called. So this is a pre and post. This is a pre, the actual test, and then post. This is the exact sequence every single test case will be called. So how does it know about setup? You can write a method with any name. I'll call it public void init or setup. You call it anything. Okay? You call it init or setup here. Okay? All you do is just on this one, you just tell JUnit that this is my at before, meaning please run me before every single test case. That is what at before does. Okay? So I'm going to change this reverser here, right? This guy, I'm repeating here. I'm repeating this line of code. See? I don't need to do this one. Okay? So what I can do here is that I will instantiate in my setup here, okay, and then hold on to that variable in my instance variable, right? Private sentence reverser. Okay, and now in my setup, I will now do this one. Reverser equal to new sentence reverser. And now I can remove this guy, I can remove this guy, I can remove this guy. Did you get my point here? So what happens is, before this method runs, it will run your at before method. It will run your setup or whatever this one is, right? You can call this method anything, it doesn't matter as long as you have this at before. So this test, before your test case 1 is executed, your setup will be called. In the setup, you can do the pre, meaning before. You can do all the work that is required to execute your test case. Okay? So I need the instance of the sentence reverser, and I want to hold on to it in this variable here. Okay? And now in this test case, I can use safely reverser.reverse, and then I can assert, and now I can remove this extra line of code, extra line here, extra line here, extra line. Yep, very succinct, very nice. Okay, I can remove this unused import. How do I do that? Control Shift O, organize imports. Everything is cool now. Let's make sure if it really works or not. Hey, all 3 test cases passed. So what did I do here? I actually refactored the actual test case also. I improved it. I improved the design of my test case. It is very important because this is where you'll be spending a lot of time. So you need to make your test case, test classes look clean. It is very important. Okay. And now I want to write one more test case. Actually, I want to put one more scenario here in the original when business people have given me this one. What they told me is, hey, if at all you give null, okay, if at all my input is null, then you need to throw me an exception here. Illegal argument exception. You need to throw this exception here called illegal argument exception. Okay? If I give you an null input, you need to throw me an illegal argument exception. That is one of the scenario. One of the scenario. So we need to write the test case for that, right? Let's go write the test case. How do I write? Okay. Public void. Okay. Null input should throw illegal, should throw exception, let's say. Okay. Now here at test. Okay. And now I'll say reverser dot reverse, and then I'll pass null. Okay. So should throw exception. But what exception? Business user is clearly saying that it has to be illegal argument exception. This is your requirement. How do you make sure you are really getting that exception? Well, on your test annotation here, there is one attribute here called expected. Okay, expected equal to illegal argument exception dot class, or whatever the exception that you are expecting. Meaning what you're saying is, this particular test case, I'm expecting illegal argument exception. You need so I'm expecting illegal argument exception to be thrown in case, from this particular unit test, right? So I'm passing null input, and let's see if it passes. Let's see in all the 4 test cases that will pass it all. Oh, fail? Actually, what happened? Did I run only one? Okay, I ran all 4. See here, all these 3 test cases pass, but here it failed. Why? Let's make sure what's happening. Unexpected exception. Expected illegal argument exception, but it was null pointer exception. Where is the null pointer exception? Line number 6. Line of code, there is a null pointer exception. What does it mean? The object is null, and when you call a method on null, you will get null pointer exception. This input is null. Null dot split will obviously throw null pointer exception, right? But what you are expecting here, what did your business user say? He needs illegal argument exception. That's what your unit test say, but your code is not behaving that way. That's why this failed. I'm sorry, this failed. Okay, you are expecting illegal argument exception, but what is happening here is that it's getting a null pointer exception. Now, how do I fix it? Can any of you tell me how I can fix it? Sean?
We can throw.
Any of you? Okay. How can you throw? Tell me.
You can throws verb.
Tell me.
The line of the, no.
Tell me the code.
Throws,
Any of you? Madhavi?
no, I'm saying, okay.
Yeah. No.
Instead of passing a string, pass integer value.
If it is null, then you
Integer
put
value.
throws.
It's no way related, actually. What? It's a null input. Rohit, are you the one who is speaking, man?
Yeah, if input equal to null,
Yeah.
If the input is null, instead of
null, then throw.
instead of string, pass integer. Does it make any? How does it relate, actually?
Illegal argument, right? I'm thinking that point of view. Illegal
Okay,
argument.
if input equal to null, then throw. You have a throw verb, which you taught us some days
Exactly.
ago.
So if input is null, okay,
Yeah.
then yeah.
Throw.
Any of you, what should I write here? If input equal to
Throw.
null, I need to throw illegal argument exception. Throw new illegal argument exception, right?
Oh,
Illegal.
you still need that new, right?
Absolutely,
Okay.
right? And then you can put some message here. Null input is not allowed. Something like that, right? You don't know? Exception handling. Come on, an exception handling. This is how you raise a new exception. This is how you raise a new exception. When you're transferring money from checking account to savings account, and if you don't have enough money, you will say the throw new illegal insufficient balance exception. This is exactly how you raise the exception. This is the difference between throw and throws the other day we talked, right? And why? Tell me one thing, every one of you, when I'm raising this exception, how come my compiler is not slapping me and telling me that, hey, you need to declare that in your method signature? Why is it not telling me that?
Because it's a runtime exception.
Beautiful. Excellent point, Madhavi.
Unchecked. Yeah, runtime.
Exactly.
Yeah, unchecked.
This is actually
Thanks.
a runtime exception. If you want to verify that, you can definitely verify that. Right? So there is a illegal argument exception already. I'm using one of the Java's exception, that's all. It is actually, its dad is runtime exception. That is why it did not tell me. Okay, it's one of the runtime exceptions in the Java, like a null pointer exception. So null pointer exception is exactly same thing. So null pointer exception also, that is runtime exception. That is why when you throw null pointer exception or when someone else can throw, compiler doesn't force you to really catch you. Okay, now let's make sure and see if it.
Okay, could you have done it by putting throws on the line of the method?
You mean here?
On the top.
You mean here?
Reverse, yeah. Yeah.
Here, absolutely.
Yeah.
You can say throws illegal argument exception. You can definitely do it. No problem. Compiler will not argue, or your test cases will not argue. Nothing will happen. Okay. But the only problem is, the only point, there is no problem. The only point is you don't need to do it because this is a runtime exception and compiler does not force you to do it. You don't gain anything. You don't lose anything. You don't need to do that. It's an extra code. You know what I'm saying?
Okay.
But let's say our business user says that null input should throw exception. What exception? Bad input exception. Okay. Let's say bad input exception. Hey, let's revisit this guy. So my business user, we all decided, we are all in one team. We said that, you know what? Illegal argument exception is a runtime exception. We don't want to use it. Actually, we have to tell everybody that, our method can potentially throw bad input exception. So let's create this exception, right? Let's create bad input exception and your superclass. I'm designing my class to be like checked exception. How do I do that? Well, extends java.lang exception. That's it, right? Are you guys with me? Hey, this is how you create your own class, your own exceptions, right? Now, bad input exception. Now, let's make sure my test class is passing. No, unexpected exception. Sorry, you are expecting bad input exception, but what is thrown is illegal argument exception because now let's go change this guy. And now, if at all input is null, then I will throw new bad input exception. Okay, I know there is no constructor here that takes the string. We can add a constructor here if you want. Bad input exception, string error message or string error, and I don't want to do anything. All I want to do is just call there is a super in exception. There is a constructor that takes a string error message. I'm just calling it. Whatever it does, I don't need to do anything. See here? Now, this is all good. But compiler is slapping me and telling me that unhandled exception type bad input exception. Sorry boss, you are throwing a checked exception from your method, but you are not declaring, you are not telling your clients that you could potentially throw an exception. A checked exception. That is what it is telling you. Now, how do I fix it? Just say throws bad input exception. Meaning what you are telling here in your method signature is that, hey, what you're telling here is that, hey, when you call me, you could potentially get this bad input exception. Be ready to handle. That's all you're saying. Simple. Of course, you need to handle in all these cases here, right? So if you want to, there are several ways. You just declare throws to your test class itself. No big deal. This is good enough. There is another way. What you can do is you can catch the exception, and then and exclusively, if you get bad input exception, you can say fail, assert.fail. Let's make sure hey, all the 4 test cases are still good. Very good. Did you guys get that? Did you get that? Anybody has any questions about that exception? Sean, at least you asked, did you get the clarification on that?
Yeah.
You're good?
Yeah, okay.
Wonderful. Anybody else? All of you good, I'm assuming. If not, I can explain again. Okay. That's about it. I mean, it doesn't matter. You can throw bad input exception or illegal argument exception. It doesn't matter. Okay, now let's see. Let's say there is one more scenario here. For null, okay, this one. How about blank? If I pass blank input, okay, then even in that case, I need to get bad input exception. Okay, you should not take just empty string, bunch of empty spaces. Hey, Rohit, actually, did you get clarity on these exceptions? Because you said something.
Yeah, I got it.
Okay, wonderful. Now let's make sure. Now let's write one more test case, right? What is the test case? Public void empty input should throw exception as well. At test, and then I'm expecting bad input exception. That is what my user said. Okay, and now I'll say reverse dot reverse. I can give some empty string like that, okay, or some string like that, some empty string. I know this method. See this one? See compiler how it is telling you, hey, this method you could potentially get bad input exception, so be prepared to catch it. So do something. Either you catch it or rethrow it. Well, I don't want to catch it, so I'm rethrowing it. It is doing it because it is a checked exception, guys. Don't get confused. Excellent. Now let's make sure. Ooh. 4 test cases passed, but the 5th one failed. Unfortunately, failed exception because expected exception is this one, but it is not throwing it. It's not throwing it. Now let's go. Let's implement. Where is this guy? If input is equal to null, we are handling it good. Okay. Else, do you know how to do that? Else, if input. Here I'm sending some empty braces, right? Sorry, empty spaces, right? Do you know how to trim those empty spaces in Java? This string has a method called trim. Do you know that? Once you trim it, it becomes like this. There is all the spaces are gone, like it will be gone like this. Okay, so you trim the empty spaces and finally check the length. Or you can directly check is empty. So there is a method called is empty. Here it returns true if and only if length is 0, meaning if it doesn't have anything. You can directly put you don't have to put this trim. Okay, you can directly check this one, but the problem is if you give empty spaces like this, right, it wouldn't give you that it is empty. That is why you need to trim all the empty blank spaces and then check if it is empty. If it is empty, then you again want to throw bad input exception. This time it is not a null input, but it is actually empty spaces. Empty input is not allowed. Right? Now let's make sure if that's the case. Beautiful. All 5 test cases passed. Agree? So this is how you test drive it. Every single scenario, you write the test case first, quickly make it pass. That's red and then green and then refactor and improve your code. Okay? And improve your test case also. This is good.
Can you please explain this one more? What will it do if we give trim?
Oh, yeah, absolutely.
So Venkat, we have done exceptions. We haven't done exception class, right? Yeah.
We did.
Okay, I missed it. Okay.
That's the homework part, right? We did.
Yeah, homework
a
part,
week or 10 days back. Yeah.
Okay. I haven't done the homework then. Okay.
Yeah. Yeah, please do it. Okay, now I'll explain about this let me tell you with an example, okay? String trim demo. String str equal to just empty, okay? See here. So it is telling you that this is empty, right? Now, see this one? It is empty spaces here, Uma. Empty space, two empty spaces. And now I'm asking this guy, hey, are you empty? Is empty. It is saying false. You know why it is saying false? Because behind the scenes what it does is str.length. There is a method called length. If length is 0, then isEmpty method will return true. Is length 0? No. There are empty spaces. There are white spaces. There are empty spaces. Are you getting it? But these empty spaces, you know, we don't want empty spaces. These empty spaces are also considered empty for us, right? In that case, what we want to do is, actually I'll show you this one. See here, length equal to, I'll just str.length. See, the length is 2. If you give 100, if you give a lot of spaces like this, right? So your string will tell you that there is a 14 here. So, but if you get this one as an input, do you want to proceed or not? Uma, you don't want to proceed like this, right? Because this is all empty spaces. So what you want to do is, you want to remove the empty spaces. So what string str equal to, because it is immutable, str.trim. Now look at it. Now you have length 0 because I trimmed it, meaning when I trim it, all the white spaces are gone. Okay. Now let's say somewhere in between I gave 65, right? So do you want to look at it? System.out.println str equal to, do it like this. Do it like this. See here, if I have 65 somewhere in between and I have empty spaces before and empty spaces after, okay, this is how it will remove. Sorry, this is how your string will contain actually. But if I say str.trim, observe the output now. So if you say str.trim, it will remove the white spaces before, it will remove the white spaces after, because those are useless. That is what trim does. Did you get that point?
Okay. Yeah, I got it.
You got it, right? So use this. A lot of people use it. I believe there is an ltrim also. No? There is in a lot of programming. I don't know. Maybe there is a. Actually,
that's in SQL.
There is an in
SQL
you have
trim and trim.
Exactly. Right. In SQL you have it. So that's about trimming. Did you get the concept, guys? Everybody? The whole concept of TDD? Yeah? You want me to do one more example so that it will be more clear?
Yeah. Venkat, could you please paste? Venkat, just repeating. So TDD is when you want to access one individual method, right? Gone.
No.
No.
TDD means you are test driving it, meaning your test classes drive the actual class, actual functionality. Yeah. So without writing the test class, you will not write a single line of code. That's the point.
Okay, but you're doing it. You're attacking a specific method within a text, right?
Each one of them is a test case. Each one of them is a test case. We are thinking like a testers now.
Okay. Okay. No, see, as opposed to the J unit, in the TDD, you are having the ability to attack a specific method, as opposed to J unit where it is working on the entire text.
No,
Not like that.
no, that's
Oh,
not
it
correct.
seems like that from your tape that you asked us to read.
Let me tell you again. JUnit is a unit testing tool that you use it. Okay? So JUnit will help you do the unit testing. TDD is a special technique. It's a technique. It's not a technology. TDD is a technique, not a technology. JUnit is a technology. It will actually help you write your unit test. This is a 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 unit test. So TDD is a technique where you will not write the actual code until you write the failure test case. That's it. So your tests will drive the actual code, meaning you have to write the first test. You have to write the test case first and then write the actual code, test it, and again write one more test case and write the code, write one more test case, write the code for that, write the one more test case, and iteratively you will run all these test cases, and your goal is to make all of these test cases pass. Did you get that point?
Yeah. I got it now.
Sure.
But actually, from your tape which you asked us to see, it seemed there was something where it is possible to really, instead of really going through all the methods, if you wanted to test one specific method, there is a technique for doing that, isn't it?
In JUnit, right? This particular method that you you just highlight this method and right-click, run as JUnit test.
Okay.
You can do that.
Okay, maybe that's why I got confused.
So
okay.
it's just JUnit is a technology, okay, or a framework, unit testing framework. That's what we call it, right? Unit testing framework that will help you with the unit testing of your code. So, but TDD is a technique where you write the test first. Okay,
yeah, that's fine. That part is
so
understood.
you don't have to do this way. What you can do is you first write your sentence reverser completely like how we did in the previous class, okay? And then you write the test cases. Definitely you can do it that way, right? That is test after. So you can definitely, you're making sure every scenario is covered. But with this technique, TDD technique, you're absolutely making sure that every single scenario is covered here. It's possible that, because you already wrote the code, right? It's possible that there is some code that is left out without getting tested. Does it make sense?
Yeah.
Huh?
Yeah.
Okay.
In real time, how many codes should we write like this per day?
Actually, I thought, in real time, people don't do it that much, but I'm seeing it now. I'm actually writing it on a day-to-day basis. So,
You mean at your work?
we do it this way.
Oh.
It doesn't matter how complicated this one is. Okay, we'll always start with this one. There is a technique in unit testing called mocking. Very, very, very important concept. But before we talk about mocking, I'm not sure whether we talk about in this batch. Not sure. If I have time, I'll talk about it. If not, I'll see. There is a concept called mocking. Once you understand this mocking, really, you can unit test anything. Okay, there are some nice mocking tools out there, so you will use them. I'll definitely not talk about it today. I think it's too much because we need to digest this one with another example, and then maybe one day.
So for unit testing, you can unit test your your MVC and servlet and all those things also?
That is subjective. Simple Java classes can be very safely unit tested. Okay.
And Venkat, we are using only one method, right? Assert equals. Are there any
there are a lot of methods. Actually, Oh, good point. Actually, I'm glad you asked this. Assert has, see, assert true, assert false. You know, you call a method that returns a Boolean, okay? And if you want to make sure it really return false, then you can do assert false. Then there is a method called assert true. Okay, when you return a method, if that returns a Boolean and you want to make sure whether that's true or false, then you can whether it's true or not, you can use this assert true, assert equals, and assert equals again assert null. See, you're making sure the object is null. I think assert not null is also there. Yes, you're making sure an object is not null. So you have a lot of these assert methods. Hey, see this one. How many overloaded methods? I think when I talked about overloaded, I showed this example. Assert equals. This is for Boolean array, byte array, char array. This is string with the message. Okay. Actually, there is another overloaded method in assert equals where you can throw the customized error message. Here, the first argument takes a sentence with one word failed, something like that. You can give a customized error messages. So if at all this failed, then this is what will be shown on the reports. Actually, JUnit will generate a lot of reports too. So it's very, very, very important tool. Anyways,
even Selenium, there is a tool called Selenium, right, which tests Java applications.
Selenium is used for web testing.
Oh, web
Selenium
testing.
under the hood has some web drivers, like they open the browsers automatically. Hey, if you want to go to, like, I don't know, let's say I want to go to CNN.com and make sure if I'm testing this this website, on the left side you have to have this one, and here you have to have a US edition. If I click on this one, I have to get this International Arabic Espionage. If you want to test all of this, that's the web testing. That's when you'll use Selenium and other testing tools.
Oh, got it. Okay.
Okay.
Yeah, that is basically used for functional and as well as the load testing.
Exactly.
Selenium and JMeter and
And actually, some people use this QTP as well. QTP under the hood, it's kind of the same thing.
yeah,
You can automate all of this. Okay. Yep. Now, which one you want to take it? I can take a complex.
One quick thing. Could you please paste the website? Could you please paste the website for that 4.12 on your screen? I'll just copy it.
Definitely.
Because I did download from Google, but the point is I want to copy from where you did.
Download and install. No, it's pretty simple. Yep. Definitely. Okay. Now let's go back here and then let's take one more example. Huh? Which one you want me to take it? I need everybody's input this time. We all do it together. It doesn't matter.
While you're watching GoToMeeting, you can take a picture of your screen. It's right there.
Okay.
That's also
Where?
on the screen. You'll see a camera button.
So which one you want to do it, people?
20.
What is the 20? Write a method to return first 100. Complicated example. Huh? Okay. You have to tell me the logic. Okay. Let's write down.
I don't know the logic and all of that, right?
Let's write down. So Fibonacci or Fibonacci series. Fibonacci.
You can, others can, their opinion, I just do.
Absolutely. I mean, it doesn't matter. We can take one, right? Fibonacci numbers test. Okay.
Start with 0 and 1.
Okay. Let's make sure Fibonacci numbers are 1. Oh, it starts with apparently 1. 1, 1, 2, 2, whatever. Let's write down. So what's the scenarios? Tell me, you tell me the users, hey, I'm only writing the code here. I don't need to know the logic, okay? So you tell me, you guys help me with the logic. First of all, forget about the logic, right? Forget about how to write it. Don't worry about how to write. We are all testers here, okay? We're all wearing the testing hats now. So what is Fibonacci numbers? How do we know that when a code is giving, how do you know that it is working right? So let's go down to the definition of it. I don't know the definition, but I can understand. So this is what Fibonacci numbers: 1, 1, 2, 3, 5, 8, 13, 21, blah, blah, blah.
You use that for agile also?
Yes, for story pointing, right?
Yeah.
So first 100 Fibonacci. So if you actually do a first 100 Fibonacci series, first you have to know what you have to write in your test case that the 100, right? Okay, let's take one step at a time. So tell me, what is the scenario? What is your input, or is there any input? No?
The input will be, I think, instead of giving first 100, up to what length you will go.
Okay.
To what distance you
So
will go.
let's do this one. That's a great point, Shovan.
The input will be 100 in this case.
Let's do why don't we take it, input will be 100 eventually, but why don't we take this approach?
2 seed values, 2 numbers to start with.
0 and 1.
Yeah.
Okay. So what do you want to do? Input 1,
Put
input
x
2.
equal to 0, y equal to
Okay,
1.
if I give you 1 and 1, what should it give? Tell me, this is my input.
2.
And what should
2.
it give? Huh?
2.
Okay, and then tell me.
And then 2 plus 1, 3.
What? What are my inputs?
1
Now
and
in
1.
this case, no,
1
no,
and
1, 1, 2 he has already done.
1, 2, 3.
And 2
No,
and 1, 3.
if I'm giving this method 1 and 1, it is giving me back 2. Is that correct?
Correct.
Is that what you guys are saying? Okay, whatever. Yeah, now tell me what is the next input. Next scenario, this is one business use case, right? We'll write the test case for this one. Now next tell me.
No, see, the way I'm saying is this. See, the Fibonacci series has its own
I
specification.
understand.
You know that.
Sean,
Okay.
you understand my point first. Okay? I got this one totally. Now tell me, break it down and tell me how we want to test it. Simple. That's my point. That's what I'm asking. What is the input and what is the output is simply I'm asking.
Okay, I have to know the output.
So one way
when you
to
input up to,
guys,
when you input up to, then you will get the answer 3, right?
can I say something? Sorry, Ketan. We are going, you guys said something, right? Now let me put different perspective. One way to skin the cat is, there are several different ways, right? What I will say is, you pass me the number. How many Fibonacci numbers do you want? Okay, I will pass, let's say 2. If I pass, then you have to give me 1, 1. I mean, let's say int array. Let's say, the return is int array. That should have 1, 1, right? Now, if I give you 3, then you have to give me 1, 1, 2. If I give you 4, meaning I'm asking you to give me the first 4 Fibonacci numbers. Is this fair? Unit test case?
Oh, you're going reverse.
Okay, he's
I'm
going to not
I'm
reverse.
just throwing out the idea. Just one way to
Okay,
skin the
okay,
cat. I'm not saying this is the way. I'm no way saying that.
Yeah.
This is just
the way.
one way to make our unit testing, to do whatever we want to do it. 1, 1, 2, 3, 5. Okay. And if I say, hey, give me the up to 6, then you give me 1, 1, 2, 3, 5, 8. And you give me 7, then I will give you 1, 1, 2, 3, 5, 8, 13, like that. If this works,
then
then
in that case, we need one good program, reliable program, which should give you the right output. And from there, we should take the output of your assert statement.
do we care
And the
about the
Fibonacci
program? Do we care about the how? No. Yeah, I think you are jumping the gun. We go, what is the scenario? First write a test case that works with 2 input. Just hard code this one. Write the 3. Hard code and figure out how you can quickly achieve this one.
Okay.
And then this one.
Okay.
Yeah, are you in agreement? That's how we did just now, right?
Yeah.
Because the main purpose here, Shovan, is that we don't want to write a line
Yeah,
of
yeah.
code that is not tested. So we
Yeah,
don't want to write any line of code for this one. I don't want to write so generic, start with, okay, for loop. I don't want to do that. It's that simple. Make sense?
Yeah, yeah, yeah.
Okay.
Then we can do a sys return 1 plus 1 plus 2.
We will
For
see.
1, return 1 plus 1 plus 2.
Whatever you say. I don't know how to do this one at this point. So I need all of your input. Okay? But I'll drive this whole test drive. I mean, I'll drive this exercise and show you how to do this one. Right? So, what is the unit test?
We're doing TDD, right?
Fibno 2. First two numbers, right?
Yeah.
First two numbers should return, or Fibonacci should work for, Fibonacci should work,
Fibonacci F1. What's the harm in inputting F1?
Fibonacci should work for two numbers. Okay?
Okay.
I'm just starting with the most basic and let's figure out I'm sure it will help. Now, I don't want to think about the logic first. I want to talk about assert equals, okay? So, what is my expected? Expected is, if I give 2,
An array.
An int array.
one second guys. Fibonacci numbers, okay? F equal to new Fibonacci numbers. F dot generate, okay? I know, at this point I don't even have a class. So let me go ahead and create that one. Simple. Now let me go ahead and create this guy. And now it should give me an int array, right? That's what we are saying, int array. Okay. Int array result or output, right? Now we are changing the method signature to int array. Very good. And then we'll say we have to give something, right? Return new int array of 0. I'm giving empty. Okay, I am just giving an empty array. That's all I'm giving to start with. What is my expected? What is my expected? Int array expected equal to new int array of, what should I get back? 1 comma 1, right? Make sense? If I give 2, that is what I should get. Now my result is, generate, I should give input as 2, right? I'll change this guy, int input. If I give 2, I should get 1 comma 1. I'm saying first 2 Fibonacci numbers. My expected is this guy and my actuals, my result. Okay? There is a assert equals that takes array also. Now let's go ahead, run as JUnit test. Failed. It's expected, but it was okay. So what do I do now? How do I quickly make it green? Just hard code, right? Can I hard code? Just say 1 comma 1. One comma 1, I hard coded, and then it's failing because it's actually doing the object equality It's not doing an array equality. There is a wrong method I'm using. I should use asset array equals. Okay, this is my expected and this is my actual. Where is my actual? Is result. Okay. Sweet, it worked. Okay, if I don't give this one, if I just do an empty, it should throw an error saying, hey, sorry boss, you are expecting length 2 but actual length 0. Length itself did not match, so obviously it didn't match. So we did it, quickly made it green. Okay, now what's the next step? What is the next step? Fibonacci should work for 3 numbers, right?
1, 1, 2.
Yep. So meanwhile, I'm going to write my setup, public void setup or init, whatever that one is. At test, sorry, at before, right? I'm enhancing private Fibonacci numbers f, or yeah, whatever that one is. I'm saying f equal to new Fibonacci numbers. Make sense? And now I don't need to do this one. I'm not repeating this guy. This is fantastic. This is good. Can I inline this one too? I can actually inline this one. You know what is inlining meaning? I don't need to create a separate variable here directly. I can say this is my expectation, and it works too. You can write it all of this in a single line if you're comfortable. If you're comfortable, so I'm calling the generate method here. It is generating, and this is my actuals, and this is my expected. You can do it. Sweet. If you're comfortable. If you're not comfortable, if you think this is more easy to understand, then do it that way. I'm easy either way. I'll do it this way. I'll inline. I hope that's fine with you guys. Okay. Now, less code is better for me. Now let's do it. Fibonacci should work for 3 numbers, right? So if I give first 3, then what should be my output? 1, 1, 2, right? That is my output. Oh, the first one is successful, the second one failed. Array expecting 3 but actually 2. So it failed. So how do we make it quickly green in such a way that both of these are green? How can we do it? I mean, you can go and do like this. If input is 2, then return this guy, else really not much, not useful, honestly, but you can. Oh. You can do it this way. Yep, so you can make both of them pass quickly, and now you come back and refactor because this is not the original code. So now start writing the actual code. About the logic. So how do we think about the logic here? So can one of you help me with the logic here? So the first two numbers are always constant, I believe, 1 and 1, right? And now from the third number onwards, you will add the previous 2 numbers. You will get the result, right?
Result plus previous number, yeah, then after.
Sorry, what did he say?
Result plus previous number, then after moving forward.
Exactly. So let's write down our algorithm here. Let's write down, before writing the code here, let's say int first number, right? I'll say F1 or number 1, N1. This is number 1. N1 I'll have 1. Int N2 equal to 1, right?
Yep.
Right? Tell me, let's say the size is 3, right? Okay? Now, if the size is 3, we already have N1 and N2. Let's say we take a list here. Okay, it's easy to add, and finally we'll convert this list into array easily. So we'll say list of integer. Okay, result equal to new array list, right? New array list of integer. Yeah, I think you got it. Right. Now we have 3 here, right? Now we have to write the for loop. Now we write the for loop from all the way till 0, okay, all the way till 0 to 3, okay, I plus plus, I mean obviously less than 3. So we have 0, comma 1, comma 2. Now, tell me, do we need actually both the numbers here? Probably not. Let's take a look at it. What do you guys think? I need help here. Int, let's say sum. Okay, let's say sum. I will say int sum equal to 0. Now, if it is 0, meaning the first number, then I know that I will have to add 1. Sum equal to sum plus 1, right? If it is 0 or 1, I have to do this one, right? But before sum plus 1, I have to add to my result, right? First I have to add 1 to my result, right? And then I will add I'll make my sum 1, and then when I get the second one, I will again add to my result list and then make my sum 2, right? And now when I come the third one will be 2 is my sum, and what should be the result actually? 1, 1, comma 1, 1, 2, right? So for the first 2 numbers, we just blindly add it here, and the result sum equal to 0. And from the third one onwards, we'll say sum equal to sum plus this one by adding this guy. And the next one is 3. Next one is 3. How am I getting the 3 here? My current sum is 2, okay? And I need to hold on to my previous number also, right? So I need my current sum and the previous number. I need to hold on to both of them. I know it's a little complicated. We did this back in the college days very well, I think. So tell me if there is a better way. Let's do it.
You just need 3 int, that's all, and keep flipping 3 int numbers.
Yep, that seems to be the case. So let's look at it. Tell me, Venkatakrishna. Now, list. Okay. First, I'm holding on to all of these values. Result equal to new array list. Okay. int sum equal to 0, int previous number equal to
1.
int previous number equal to 1 to start with.
Yep.
Sure. Let's do for int I equal to 0, I less than input, okay, and then I plus plus. So if I equal to 0 or
Or 1.
I equal to 1, meaning first two numbers are special. That is my point here. First, my comment here is first two numbers should be in Fibonacci series. First two numbers in Fib series should be 1 and 1. Okay, that was my point here. So we will add, okay, result dot add. So we add it to the number, okay, in both the cases. And now at this point sum 0, okay. Now the third one onwards, tell me else. So now we got the 2 here, right?
Yeah.
0, 1, now 2. So 2, which is 0, 1, 2. So now what do I do here? Sum equal to sum plus I, right? Now I got the sum. Now I got the third element as this guy here, okay? Because currently sum is 0 and 0 plus 2 is 2. Now I will have to add that as a third element here. Okay? And now, how do I make my previous number? Previous number at this point is 1 only, but I need to start making...
So previous number will become sum then, right?
My previous number will be sum. It should be sum, but the only point is, it should be, I have to start doing that from the third element onwards, not for the, no, even at the third element, my previous number is actually, no, at this point my previous number is 1 and it is good, right? So starting from here, oh yeah, I think you're right. So the previous number, okay, my sum becomes the previous number. And now let's think about this one. This one is actually faulty logic, right? Because the previous number plus whatever the I becomes the sum. Agree? Yeah.
Previous number plus I, you are right, sir.
Right?
Here is previous number is equal to sum, yep.
Mm-hmm.
Right.
And now if you want to print at any point, actually let's go ahead and print this guy, before we return it. And actually list of integer can be converted into int. There is a way, actually, result dot in list, there is a method called toArray. ToArray new int of like that. Yep. So this is how you can convert from list of integer to array. And then, but the only problem is that it is giving integer array here. What are you saying here? The method must return a type of, okay. Oh, I'm sorry. There is no return statement here. Excellent point. Cannot convert from integer to int. Okay, that's fine. I'll change this guy.
So it was not able to convert from primitive to object, so you have to bring it in object, right? That's what we did.
Okay, that's the logic. That's the maximum I could think. So let's make sure if our code works. We wrote too much code already. Oh, it was expected 2, but it was 3. So here, which one failed? This guy failed. Huh? So arrays first deferred at element of 0. Expected 2, but was 3. Okay, let's print it. What's happening actually? We can print definitely. I know this is complicated example, but it's, come on, we're all 1, 1, 3. Yep, there is some flawed logic. Let's take a look at it. Okay guys, if it's 0 or 1, we are good. If it's a 2, then what we are doing is the previous number here is 1. So we are saying 1 plus 2. Yeah, this guy. So should we say previous number is 0 here? Because it will only be used here anyway. 0 plus 2, and now sum becomes 2, and then result dot add. Now the sum becomes previous number. Yeah, right? Hey, worked. Now let's make sure both the test cases worked, right? Now let's make sure that it works for other test cases too. In fact, you can write, you don't need different methods actually. You can write like this. In one single method, you can write different asserts like this. Okay? You can write different asserts because it's pretty simple one. We don't need really a lot of complicated things. Fibonacci should work for.
So Venkat, if we write like different assert statement, it would treat as a separate test case, isn't it?
It does not. It one test case only. If any of them fails, it will the whole test case.
Okay.
Make sense?
Yep.
Now 1, 1, 2, 3, right? Okay. Let's make sure our code still works. Failed. Array first detected expected 3. Hey, see here. 1, 1, 2, 3. We failed here miserably. 1, 1, 2, 5. Why? Let's 1, 1, 2, 5. Excuse me. Result dot add. This is all good. Now until 3 numbers is good. Now when we come to the fourth one, okay, at this point, what was the previous number? Earlier 2, right? Okay, 2 plus 3, 5. So 2 plus 3. The previous number. We need to write some special logic. It works for everything else, but the first anybody? What are we doing wrong here? So previous number. So when we come here, the fourth element, the previous number was 2. 2 plus, the previous number was 2. Actually, the previous number should be 1. Previous number should be 1 if this is the third one, right? And fourth one, when it comes, the previous number is 2 plus 3 equal to sum. Oh, what am I doing here actually? Look at it. This is 0, 1, 2, 3 elements, right? I'm supposed to actually sum up previous 2 numbers. I'm summing up with I. That was bad. Agree? In fact, we are putting all of these
All those previous
here.
two numbers, yeah.
Exactly, right? In fact, we're actually storing all of this into list, guys. Okay? So what we can
Actually, limit.
what we can blindly do is this is what we can do, right?
Yeah, you can loop through that same thing, but only thing is just keep adding the last two and change them. Add them and change them. Add them, change them.
How about this one? Previous number 1, okay, equal to, we are actually storing here, right? We know the size of the, right? Int size equal to result dot size, right?
Yeah.
Right? So at this point the size is 1, we know that, right? I mean 0, 1, so size is 2. So what we can do is that previous number 1 is result dot get of size minus 1, right? Understand? And then size minus 2 will give the previous one. Why are we thinking so much? We are actually luckily storing all of these numbers into this one, right? And then you just previous number 1, previous number 2, right? And you result, you don't need this number also. You don't need this guy actually. You directly say int sum equal. You don't need to maintain any of this. I mean, with the way we implemented it, right? Fantastic. And now,
Yeah.
makes sense, right? I'm not saying this is the best way. No way you can quote me as the best way to do it or anything like that. No way. There may be space complexities, time complexities. There are a lot of things that people say, hey, why are you storing all of this? Yeah, I know. Don't worry. So 1, 1, 2, 3, 5, 8. Hey, all of these are working. Fantastic. That's what it is. We thought too much here. We don't need to. Just because here we are using list and list maintains the position, right? Simply get the previous two numbers from the list and then sum it up. What's the big deal? Right? I mean, this is not the best way to do it though. If you go back to the real programming techniques, because you're actually holding all of them into memory. Without having to hold all of them, you can do it, but that's okay. We looked at how to use this list, and this is one way of doing it. Make sense? You test drove it. Fantastic. Anything else? Oh, by the way, the other day, just 2 days back, I got an idea here. I wrote here, I did not tell any of you. See here, I wrote this method. Write a method to accept a sentence and return a map of how many times each word appeared in an alphabetical order. Words are space separated in the sentence. So what I'm saying here is that if I give you how are you doing? You seem to be doing good. Okay? If I give you a sentence, what you need to give me is each word, okay? How many times how appeared? How appeared one time. And then are appeared one time. You appeared 2 times. Doing appeared 2 times. Right? All these words. Good appeared once. Can you give me this way? Can you give me the answer this way? And I want this to be alphabetically stored. So what I'm telling, sorry, Krishna?
Contains method can do it.
Do whatever you want, whatever the implementation, I don't care. Okay, do it however you want to do it, but I need the number of times. You give me a map here. Did you all understand what is the data structure we use here? This is a string, this is an int. How can we store something like this? What kind of data structure are you using? Key value pair, yes. Map of string integer. Okay? Like this. So this is your word and this is number of times it appeared. This is the word, number of times it appeared. And I want in alphabetical order. Can you guys do it at home? Okay, I'll send this across. I think you got it also. So this is the question. I'm pasting it here. Okay, that's it. So that's about unit testing, TDD, basics. It's not end of it. It's just the introduction part. There's a lot to it, but well, we'll take one step at a time. That's all I have. Thank you so much, everybody. Any questions? Anybody?
Not me. It's okay. Thanks.
Yeah? Did you guys like it?
Thank you.
Yeah.
You guys like
So
it?
Venkat, next day we are doing what?
Excellent.
Okay, thank you. Let's see. Next day I will let you know because I want you to actually practice on this one. Okay?
Okay.
Practice tomorrow and then I'll tell you. I need some feedback from you guys. We'll talk about it tomorrow and
Tomorrow?
what
Tomorrow
we
you're
should talk
meeting,
about it. We are not meeting. You guys meet.
we
You
guys are
guys
meeting,
will
okay.
meet definitely. Okay. At that time, I might jump in for 5 minutes and ask what should be the next one. And first I want you to feel comfortable with this concept.
Unit testing. Okay.
Okay. Rather than
Could
me.
you please upload the video
I will.
today?
Absolutely. It will be late though, probably 11:30 maybe. Yeah, I'll do
That's
it.
fine.
Okay.
Venkat, can you paste that one over here? I'll just copy it.
Which one?
Paste that one means you mean the place from where you downloaded that 4.2, 4.12.
Multi-threading, we'll see. Rohit,
Oh, no,
I may not talk about it in this one. It may be homework. We'll see. Because that's the least
But
important.
multi-threading, we guys, like the kind of programmers that we are supposed to become, multi-threading is not something that we would do on a professional basis, right? It's basically the deeper stuff, right?
I mean, that's not
Good to
in
know.
my
That's
not in my list. Really speaking, that's not in my top list.
Okay. Uh-huh.
There are other important concepts that I need to talk about. That could be a homework thing.
Yeah, that's fine. We can take it as a homework. Multi-threading, that's fine.
Yeah, because that's one of those things that I least worry about.
Yeah, that's fine.
Bottom of my list.
Yeah, that's okay.
Really bottom of my list. Okay.
Okay.
Because we don't really use it.
Okay, that's
and
fine.
we
No
know
problem.
the standard questions that we talk about, right?
Yep.
So that's why that's the bottom of my list. But this is top of my list. The one I talked today, unit testing and especially agile. Everybody is asking these days. Everybody is asking that, hey, did you work on agile environment? Oh yes. Okay, tell me what's your, how did you do it? So even if I talk about agile, I don't think I can deliver as good as I did back here. So that is why I asked you to watch it.
Okay, Venkat, quick question to ask you. See, in your work environment, since you worked in 2 companies previous and this one and also something before, but these other companies that are more current with you, what tools did you use for agile? For recording the ticketing and the tasks and the stories and all those things?
Good. I mean, not everybody has to understand this point. It's not.
Just the names.
It's not important to. Just because Shovan asked, I'm answering his question. A lot of the companies use this tool, Jira.
Jira, okay, that I used also.
Jira Agile.
Okay.
I mean, Jira Agile.
Okay, you're not using Jira. Fine.
And then I briefly experimented with some IBM tool earlier. It's called Rational Team Concept or something, RTC.
RTC, okay.
So, but this is the most prominent one, Jira Agile. It's an Atlassian product, and you can do it online. You don't have to download, install, kind of thing. It's a cloud-based software as service. So use it, and you can use Excel. You can use Excel. You can use paper notes. So your tool is not important. That's why I was saying, Shovan, Tool is not important. A lot of successful companies do, even they still use simple paper-based stories. Okay, they write on a sticky notes and then stick to the board. Okay. Okay, guys. Have a good night, everybody.
Okay.
Take care.
Okay, thank you, Venkat. Good night.
No problem. Good night.